gateway type stuff. Let you have some time to practice, and also we can talk about a few issues on some things. But I want to focus on 37, 38, 39 again, just quickly. Remember, we said for the arcsine function, and a cosine is very similar, we have to restrict the sine function from negative pi halves to pi halves. All right? So if I restrict the sine function, remember, when we do an inverse, we interchange the x and the y's, the inputs and the outputs. So that means this output is what is between negative pi halves and pi halves. These y values are between negative pi halves and pi halves. All right? So on the sine function, if I graph the sine function over here, we're restricting it from, we're restricting that from the inputs of sine from negative pi halves to pi halves, and the outputs are negative 1 to 1. So that means the inputs here are from negative 1 to 1, right? These inputs would be negative 1 to 1, and the outputs we're restricting negative pi halves to pi halves. All right? So therefore, if you have this problem, arcsine of 2 pi thirds, as an example, okay? Now, 2 pi thirds is about what? 2 pi is about 6. 6 divided by 3 is roughly 2 point something, right? So this is arcsine of about 2, right? Now remember, negative pi halves is negative 1.57 to 1.57. So the output of arcsine of 2 pi thirds has to be between here and here. All right, so if I do, oh, I did that. I'm sorry. That's wrong. We can't have 2 pi thirds. I meant arcsine of sine of 2 pi thirds. That's the problem. Okay, so arcsine of sine of 2 pi thirds is not going to equal 2 pi thirds, right? And that's what that 37 was getting at. Explain why arcsine of 5 does not equal 5. Okay? Because arcsine of the sine of 2 pi thirds, if you do the sine of 2 pi thirds on the unit circle, 2 pi thirds is over here. Right? Well, what is the sine of 2 pi thirds? No. Root 3 over 2. And it's positive because sine is positive in both of these quadrants. If you do the arcsine of root 3 over 2, you get what? Pi over 3, which is the first quadrant one. Because you have to get something that's between negative pi halves and pi halves. You have to get something that is between, here's negative pi halves going this way, down to there, and pi halves going to there, right? You can't get a second quadrant angle. So this would be pi thirds, right? Do that on your calculators. Everybody get your calculators out. Let's just do that again, just so we have at least have a reasonable understanding of what's happening here. Okay? So sine of 2 pi thirds is root 3 over 2, but so is sine of pi thirds, root 3 over 2. When you have arcsine of root 3 over 2, you can only get one answer. You can't get pi half thirds and 2 pi thirds because it's a function. You can only get one output out. There are a lot of different angles that give you root 3 over 2 when you do the sine. We only want the one that's either in the fourth or the first quadrant. So if you do arcsine of sine of 2 pi thirds, you get pi thirds, right? Now, the negative ones are the ones that get tricky. If this was, if we did, let's just type into your calculator arcsine of the sine of 5. And maybe some of you did already.
Oh, I did.
What do you get? I don't think you do. No. Try it again. Okay, hit, 5 minus 2 pi. You get 5 minus 2 pi, which is 5 minus 6.28. Hit Control Enter so you get a decimal. You get negative 1.28. Now let's think, okay, you don't get 5. Now again, the whole point is, wait a minute, inverse functions should cancel each other out. Well, within a restricted domain, they will. Between negative pi halves and pi halves, they will. So let's think of the unit circle. See that this makes sense. Okay? Sine of 5. Now remember, this is 4.71 down here, right? 3 pi halves is 4.71. So 5 is right down here somewhere, but that's going around this way, right? It's in the fourth quadrant, but it's not between negative 1.57 and 1.57, right? So what we get, instead of going around this way to get 5, we go this way, and that is negative 1.28. Doesn't that make sense that it would, right? Because all the way around is 6.28. So you go around 5 to here, it'd be 1.28 going back this way, negative 1.28. So it's the same angle, but it has to be written in a way that's between negative pi halves and pi halves. Okay? So this whole idea of these inverse functions and that sort of thing. Now, if there aren't any domain restrictions, we have to worry about it. When we go this way, and I talked about this a little bit in the other class because a few people asked some questions, and so we had this discussion. If you go this way, there are no domain restrictions. If you go sine and then arc sine, there are no domain restrictions because, for example, it would look like this then. Okay, this would say the angle whose sine is root 3 over 2. Well, what angle, what are you going to get out of there? We just talked about. What are you going to get out of root 3 over 2 arc sine? Pi thirds. And then you do sine of pi thirds, and that is root 3 over 2. So you're always going to get the same thing back. So if they would have asked you sine of arc sine of, well, if they'd asked you sine of arc sine of 5, I hope you would have said, what? Not possible, because what can you only put into arc sine? You can only put in numbers from negative 1 to 1 in arc sine. See, if we do this the other way around, sine arc sine, there are no domain issues other than you can only put in numbers from negative 1 to 1. Otherwise, they don't work. Okay, so this will always work. So sine of arc sine of x is going to equal x all the time. Okay, it's equivalent to this. I'll just mention this and then we'll leave it alone. But if I do square root of x squared, we talked about that yesterday. What's the square root of x squared? Absolute value of x, right? Absolute value of x. Because if I do negative 4 squared and then square root it, that is 4, not negative 4, right? Because it'd be 16 square root, which would be 4. So it's absolute value of x. But if you do it the other way, you don't have to worry about it. Okay, if you do this and square it, you always get x. Why? Why don't you need the bars? Because could x be negative in this? Can you put a negative inside the square root? You can't have a negative inside the square root. So square root of x squared, I mean, unless you get into the complex numbers, right? But we're just dealing with real numbers here. So square root of x squared is always x. There are no domain issues. Square root, so it depends which order you do them, and it's the same thing with that sine and arc sine. Okay, so inverse functions undo each other, but in a domain issue, you have to be careful. So let's talk about 39. All right, so what did 39 say? Supposed to show that the derivative of something, what was it? So we were going to do the derivative of this, right? Arc sine of x. Isn't that what it was? Derivative. Okay, now, again, if these just undo each other, if arc sine of x just undo each other, which we know they don't, right, because there's some domain issues, but if they just undo each other, then this should equal just x, right? And what's the derivative of x? 1, right, with respect to x. Just 1, right? Derivative of x is x prime, but that's just 1. So we think this answer should be just 1, but there are these domain issues, okay? So let's do the derivative following the rule. So the derivative of arc sine is 1 over the square root of 1 minus sine squared, right, which I can write like this, times the derivative of the inside, which is cosine, right, which is that right there. Now, you got to remember a little bit of trig. What's 1 minus sine squared? Cosine squared. So now what we have is cosine x on top, and on the bottom, now we got to think about this a minute though. On the bottom we got square root of cosine squared. That's what we were just talking about with cosine. That's absolute value of cosine, because cosine could be negative. You square it, it's positive. Square root it, you get a positive, but it could have started out being negative. So on the bottom, we need absolute value of cosine. Now think about this. Isn't this really 1? It's cosine divided by cosine, so it's going to be 1. The difference is the top could be negative, and the bottom has to be positive, but the top and bottom have to be the same number. So it's like having 4 over negative 4, or negative 4 over 4, right? Which would be negative 1. So this could, if cosine's positive, this would be cosine over cosine, which is 1. If cosine's negative, this would be a negative divided by a positive that are the same, which would be negative 1. So really, this is plus or minus 1 is what this is, okay? Which is what absolute value, like absolute value of x, what are its slopes? Plus or minus 1, right? Its derivatives are plus or minus 1. So that's what this is right here. It's really, its slopes are really plus or minus 1. Okay? So that's where that came from. So it's our regular derivative rule, but it's just this idea of these domain issues. But guys, it is not really going to be much of an issue for us most of the time. Okay, this kind of a thing. But there will be times, there will be a few times here and there where it's something we have to consider. So as we move along throughout the year, we start to consider some of these technicalities a little more closely. Most of the time, not an issue, but as we get better at the basics of stuff, of these things, then we can dig into the technicalities a little more. All right, let's go to page. Well, is there? Trying to think here. Any issues on those derivative ones? I'm thinking 13, 11, 13, or 13, 15, 17. 21. Oh yeah, 21. Now, didn't somebody ask about that one in here? Okay, so I did. All right, so I did give you that starting point anyway, where we can change it to cosine of 2 over x. Now, here's the thing. I helped a couple people with this, and both people did a quotient rule in here. It will work, but it'd be better if you wrote this as what? 2x to the negative 1. So we'd be better off if we thought of this inside thing as 2x to the negative 1. Okay? So we do our derivative. So our rule is 1 over negative 1, over square root 1 minus the inside square. So I usually just do this, put parentheses. I usually try to avoid doing too much in my head right away. So I would, now when you're doing a chain rule, we always say leave the inside alone. Well, that's not quite as easy to do on one like this, right? What does it mean to leave the inside alone? It means put the U right there. That's what leave the inside alone means. Okay? So this would be a case where on the chain rule, it's kind of like doing this too. When we do ln of x squared plus 2, the rule says the derivative of the outside, which is 1 over, leave the inside alone basically just says put the u down there, and then times the derivative of the inside kind of thing. So there are a couple of examples where saying leave the inside alone doesn't maybe make quite as much sense. But that's what we do right there. And then times the derivative inside, which would be negative 2 x to the negative 2. Okay? Now, the question becomes, what simplifying and that kind of stuff should we do? Well, for sure, I think we could put this up here, right? Negative times negative is positive, so we could have 2x to the negative 2. Down here, we'd have square root. Inside of here, I think we could square this easily. I mean, that would be 4x to the negative 2, power on a power. You multiply the powers, so 2 squared is 4, and to be honest, I think I'd leave it like that. I don't care if you move that x down to the bottom. I mean, I wouldn't introduce any fractions that that you don't need. I mean, like for example, this I certainly wouldn't mess with that because that could get kind of tricky. There's nothing you can do with that square root really. I would just stop right there. I'm guessing the back of the book looked a little different. They tend to go overboard on the algebra a little bit, I think. Okay. let's go to page 195, and then we'll have some work time. So if there's a few on here that you still have questions about, we can talk about them. But somebody asked about one. Oh, Jake, was that you asked me about 8?
Yeah.
You and I talked about 8.
On 195.
195.
Yeah.
Yeah. Let's look at that one. So what was that? X to the 2/3 plus ln of x. Now this would definitely be in the hard category, right? If we've got some easy, some medium, some hard, probably. I mean, on the gateway, yeah, 10 questions, probably 3, 3, 3, 3, 4, 3. I don't know, easy, medium, hard. I wouldn't get too caught up in that. What's easy, what's medium? I mean, just do the best you can. But I sit there to analyze. Is this an easy one? But just
try this one.
Yeah, well, that's just it. I mean,
I get 2.
hopefully there's not too many that you're leaving blank. If you're going through and thinking there's 9 hard ones and you didn't study it. So yeah, I hate to categorize it because then you're like, oh my God, that's an easy one. I thought that was hard. So it's a quotient rule. I mean,
So is this
what?
an easy one?
No, this would be a hard one. No, this would be hard. So, I mean, first and foremost, this is a quotient rule. It's a function divided by a function, so it's a quotient rule. Now, within that, we can see on the bottom we'll need a product rule. So when it comes time to do the derivative of the bottom, we'll have to do a product rule, okay?
Why is the bottom a product rule, not a chain rule?
Well,
e to the x and cosine different functions?
Right, because there's 2 functions multiplied together. Chain rule is when something's inside a function. So if it was e raised to the cosine x, that's a chain rule. E raised to the cosine x is a chain
Life is
rule.
a lie.
Yeah, this is just 2 functions multiplied together. Okay, now there is a little chain rule in there with that 4, but that's pretty easy. We just kick that out. All right, so derivative of the top. Now, you got to be careful here about putting parentheses around stuff on this one, especially. So the derivative of the top, since it's plus, we can just do each derivative individually. So 2/3 x to the negative 1/3 plus 1 over x. Put that in parentheses. Times the bottom left alone. Right? Now, I don't really need probably parentheses around that second thing because, it's 2 things multiplied times this multiplied, but definitely would need parentheses around this first group because of that plus sign. Now, if I was going to really get crazy with the algebra, I would, in the back of the book, they would probably put these together here, and they'd have to get common denominator. I'm not really big on making you do any common denominator stuff with the algebra. Okay, that's one algebra thing, simplifying thing you do not have to do, is the getting common denominator. Because you could do that. I mean, you could put that to the bottom, you'd have 2 fractions here, basically, and you could try to put them together as one. But I'm not going to make you do that. All right, now we got a minus. Now we got the top left alone, which again, because of that plus sign, would definitely have to be in parentheses. And I'm going to be out of room here. So we did the top left alone, and now we're going to do the derivative of the bottom. Well, the derivative of the bottom needs the product rule. So, product rule says, and so we need big set of parentheses. Go down to the next line. So, product rule would be e to the x derivative is e to the x. Leave the cosine 4x alone. Plus e to the x left alone times the derivative of cosine 4x. Now what's the derivative of cosine 4x? So I'm going to stick the negative out in front of the e to the x so it doesn't look like a minus. So that's going to be negative what? 4, so I'm going to put the 4 on it too. I'm going to put those both out in front. And then sine 4x. Right? So when I go, I'm done playing. 2 a day for two a day, multiple times a year for 17 years. All right, so so we kicked out the 4. Well, no, I forgot my hooks. Okay, so derivative cosine was negative sine. We kicked out the 4. There it is. All right, that's all the top. Here's another thing I often see with the quotient rule. You get so caught up doing the top, you forget the bottom squared. You do all this, and then you start.
Well, this is a problem I could see someone forgetting.
Yeah, that's what I mean. Especially when there's so much up there, then you forget that it's a quotient rule. So my solution to that, like I've done with the derivative inside, I always put a big set of parentheses there to make sure I don't forget to put the parentheses. If I'm doing a quotient rule, I'm probably going to start it by going y prime equals, and doing that. And so then when I work out the top here, I can remember, hey, I've still got a bottom part. Okay? So not a bad idea. All right, so now on this one. Now, oftentimes when you have mixtures of these different kind of function families, you're not going to be able to do a lot of simplifying. Now, if this was all x's, if this was x to the 2/3 plus x, and down here was x squared, for example, then there's a pretty good chance that you're going to be able to distribute and put some x's together and be able to do some things. But when you got this mixture, not always. Now, but on this one, it turns out we can. That's what makes this one especially hard. I think what we just did there isn't extremely hard. By Tuesday, I hope that this first part we did would not be that hard. Okay, after you've had enough practice at a quotient rule and had a product rule, and really there wasn't that much there to do. Each of those individual derivatives was not that big a deal. Okay, just keeping the parentheses there and so forth is. But now, what would make this one hard on Tuesday is there is a little bit that can simplify. All right. Look at this. So basically, what we have is we have a term here and a term here with a minus in between. Yes, thank you. Now, this term here has a factor. There are 3 factors, and that's something you have to think about is factors. This term here has 3 factors. This is a quantity, and then there's this, and then there's this that's being multiplied. Okay? This term over here has a factor here, and then it's got all of this. Right? Well, what could you do in this last set of parentheses? You can take out an e to the x. Now, it's a quantity. This whole thing's a quantity here. But you could take out an e to the x. So this last set of parentheses could be an e to the x and then a cosine 4x minus a 4 sine 4x. Right? This last set of parentheses here could be that. That makes sense? So I could take out an e to the x. I can't take out a cosine, right? This one has a cosine 4x. This one does not. It does not have a cosine 4x. It's a factor. I couldn't take a cosine 4x out of it. But it does have an e to the x. So this term here has an e to the x factor, and this term over here has an e to the x factor. I could take out an e to the x, and then I would have that. I would have my cosine 4x. I'd have my minus. I'd have this first set of parentheses. I'd have that second set of parentheses. Oh, whoops, I did that wrong. Sorry, this square bracket should be. Because I'm taking the e to the x out of all this. Okay, so the e to the x is out of all of that stuff. Okay, right here's the cosine minus the sine. Here's the x to the 2/3 plus the ln. Right, here's the other stuff. All right, no, you're not allowed to do that. And then e to the x cosine 4x, and then all squared is like an e to the x cosine 4x and an e to the x cosine 4x, right? And so one of these e to the x's would cancel with that one there. And so it doesn't simplify a lot. It seems like a lot of work for not much, and that's probably true. But
Would you get docked if you just have to
if I gave you this problem, that's a big if, but if I gave you this problem, on the gateway test, especially the first one, you got to earn it, right? You're going to get the first one. Remember, you missed 2 now.
Oh, yeah.
You would miss it if you had not taken out that e to the x and factor it. Now, are they going to be quite that hard, quite that messy? Probably not. But if you get a one, and you always want to look at a quotient rule for factoring something because you got something minus something. So if you can pull something out and it might cancel with the bottom, that's when you should do it. Yes, Joe. Yeah, I mean, if you're writing it as an answer, it's fine to write it like this. But when you're doing a derivative, this is where you get in trouble. If I gave you this problem, people mess that up all the time. That you'd want to write as, I hate this tablet, it's writing. In the answer, I'm fine. Yeah, that's fine. Jake, was that what you were asking? I did take one out twice. You're right. Because here we had a thing, right? A group, and then another group. In this group, in this set of parentheses, each of the 2 terms had an e to the x in it. So I took an e to the x out of those.
I got that part, but you can just
And then-
how'd you end up just one e to the x?
Huh?
You took it off.
So then let's use the black. So then this term minus this term.
You treated that as a whole term.
Well, it is a whole
So,
term because it's this times this
minus-
times this minus this times this times
so
this.
minus is separating like 3 different things being multiplied by.
That's right. It would,
Oh my
let's see. It would be the equivalent of this: a times b times c minus the quantity ab plus bc. This would be the equivalent of what we have. Similar. Okay? And so in this one right here, I can take out a b, right? And have a plus c, correct? And here I got a, b, c. All right, so I took a b out of this, but this is still one thing over here that's being subtracted, right? Now this has a b in it, this has a b in it, so now I can take a b out of that, and I get that. Okay? That's how I was doing that e to the x. It's hard to see when it gets to be such a mess of algebra stuff. And that's why I say it wouldn't be, I'm sure it wouldn't be quite that messy, the one I'm talking about doing. But but that's the idea. Quotient rule is always going to be something minus something over something squared. A lot of times you can take something out of that top that can cancel with the bottom. Yes. What about it? That's right there. Nothing. It just has to stay in parentheses though, because it's a. No, that's like. Okay, this isn't exactly the same. Let me. There we go. So if this problem had a. So if this had an EF, remember, multiplication before subtraction, so these 2 are attached, right? So I can take a b out of this, right? I can take a b out of this, and that doesn't affect this EF at all. That EF is just sitting there. So I take a b out of this. Now what do I got here? I got a b times an a plus c times an EF, or an e times f. And out of each of those, out of that group there, I can take out a b. Because if I distributed this, think about what you'd have. You'd take a b times that, you'd take a b times that. But when you take a b times this, you just tack it on.
What about, so you want to take a b times e to that? What do you do?
Uh-huh.
You do everything in parentheses first, don't you? After you distribute.
Listen. These are just 2 things multiplied. Look, if I had 3 plus xy, and I was going to multiply that by a 4, right? I take the 4 times the 3. This is what you just said, Aaron. Would I take the 4 times the x and times the y? Or would it just be 4xy? It would just be 4xy, right? So when I take this b times this thing and this thing, it's just a 4. It's just a b tacked onto those 2.
Because that's
CFA plus CCF.
Be a what now? Yeah, if you could distribute that to her and do that kind of stuff.
Wouldn't you be better off distributing before you multiply by the
In this example, you would, but not here, because it wouldn't be distributing, it'd be a FOIL. You'd have this, and you'd have this, and then it's just I'd rather keep them as discrete factors.
I mean, if you want to do it,
Yeah, I mean, yeah, that would be possible, but it wouldn't get me anywhere to do that. Well, and again, no, this is, I mean, I like this stuff. The algebra and you know, and stuff, I could do this stuff all day. But,
yeah, we know.
I know. But on the gateway test, again, if you're having to do very much algebra, you're overthinking it, right? There's going to be many of them in the 10 where you do the quotient rule and just stop. You can't do anything, right? So I don't want you to overthink it. And I don't want you thinking every one of these problems are some algebra. And some of you are going to be that way. Hopefully, you'll get cured of it before Tuesday, where you're because we do some examples like this, which are important, but you're going to be searching for algebra to do, like some crazy person, right?
Yes,
That I've driven you to. That I've driven you to. I understand that, but there's got to be some algebra. I know there's going to be, and he's going to drill me if I don't. Most of the time, not. Okay, let's pick another one.
Let's pick something like more the levels.
Okay. Well, okay.
You pick
what
you're
Yeah, you
Alright.
pick something that's.
All right, let's pick one.
36.
No,
30.
let him pick. Don't give him any suggestions. Okay, Griff. King Griff has spoken. Yeah.
Yeah, 36. There you go. Here's another quotient rule. So 36 log, and again, this is like Josh was saying. You'd want to put the cube on the outside of that, and then is it tangent x? Oh, I guess they had the cube on the outside. Okay, so they had it written the way you'd want. All right, yeah, that's true. Logs, we usually don't do that like we do with sum. All right, so this is another quotient rule. All right, so we start out with derivative at the top. So tell me what to write.
Is it 1 over?
No,
3.
3 squared. And that where it would have been a good idea to put parentheses and squared. You start on the outside.
So you don't forget to put the bottom of the part, just to do like all over.
Yeah, actually, that's what I was saying earlier. It would have been smart since you know you've got this. Yeah, and matter of fact, what the heck, start with it. Okay, why? Okay. It's like I ran out of ink for a second. Yeah, I think that's a great idea. So you don't forget, put it down there right away. Absolutely. So, and then that reminds me, I was starting to say this too, is when you bring down that 3, it might have been a good idea to go 3 parentheses 2 before you put the log in there, just so you don't forget to put the 2. Because that's another thing that really makes people mad when they fail to grinds their gears. That's another thing that grinds your gear when you fail the gateway test, and one of your mistakes was forgetting to put that 2 there.
Pass or fail.
All right, so we do that. Now wait, now what's next? We got to do the derivative inside
Times 1 over x.
times 1 over x
Plus
times
1 over
ln of 10. Now again, I'm perfectly fine with that just staying the way it is right there. Now you could put those two together as a 1 over x ln 10, but it's not necessary. Okay? Minus, oh, see, look at that. Man, I'm glad I'm not taking this gateway.
What?
Times tangent x. Now, notice I haven't really put any parentheses around stuff. Normally I do, but again, when each one of these things is multiplied, you don't really have to worry about it. A times B times C times D, you don't have to have parentheses around the A, B, C, and D. You throw a plus in there somewhere, then you better have it. Okay? Minus the top left alone. Right? Top alone times the derivative of the bottom. secant squared x. Barely had room. All over tangent squared. And you're done. See, so that's what I was talking about. Many times on a course, because look at
Because I didn't.
what could you do? Here, what could you factor out of the top? No, that's not true. There is something you could factor out.
A log base 10.
You could, because the quotient rule is derivative of the top times the bottom left alone. Okay, now, what we have is we have this thing in red minus this thing in red. Each of the red things has a log base 10, actually two of them, right? A log base 10 squared that we could factor out. Why would we not?
Because it doesn't
Because
cancel.
there's not one down here that would cancel it. Okay, now if this would have been flipped around, okay, then you probably could have. Because if this would have been flipped around, you would have had some log base 10s down here, and you'd have had some log base 10s up here. Okay, and then you might have been able to do that. Okay, you might have been able to take out a log base 10 to cancel with a log base 10 down here. All right, matter of fact, that's not a bad one to write down and try as practice. Just flip those two around and then do that. That might have some. Yes. It'd be okay, yeah. If you take something out and then you just leave it. So if the final answer is 3x plus 6, and you write 3 parentheses x plus 2, that's fine. There's no need to do it, but it's not wrong to do it. Unless you do something wrong. You know what I mean? Yeah. Yeah. Like if you factor something out and then cancel something that should be canceled or something, then that's wrong. But yeah, if you factor something out and then it doesn't lead you anywhere and you leave it, that's okay. Right? Yes.
So we should basically just like take the bottom and try to match it up with the tops to see if we should factor anything else.
Yeah, see if, what I would do is I would first
See if
look at
something
each
would
and
factor
see if
out.
something will factor out. And if it does, then say, and then would it cancel? Do
And
I need
that's how we
to?
decide.
And that's how you decide. Okay? All right. Well, let's, yeah, that's what I think. What's that? Sure, go ahead.
Have fun.
Well, I think it would be good to let you guys work now. Page 195, get together with a partner or something to work on some. And then as we have some issues and some things come up, I'll help you out. And we can talk about some stuff up here. Then you want to do a lot of work by Monday, on the website, on page 195. Monday will be a lot of, I suppose I'll answer questions, but I don't want to, like I said, I don't want to take the whole block on Monday to answer a few people's questions when some of you don't have those questions. So I may take some questions, let some of you work, whatever, but I kind of like to do work time on Monday mostly. But if you have a lot of questions or things, then it probably should, outside of class, maybe come and ask me, or during work time on Monday. And right now, okay? All right, go ahead. Go ahead and work. Yeah, if you want it, that's a great question. I'm glad you brought that up. They use all these different input variables, U and W and theta, and they're just showing you that those could be input variables. So these are all with respect to that input. So you're not having any U primes or Z primes or whatever primes. You're doing it with respect to W or Z or theta, whatever's there. If you want to change them all to X's when you work them, I don't care. That's fine. The ones I give you are all going to have X. Don't forget about implicit differentiation too. Yeah.
All 61 of them?
Like,
That's not all of them. I've done
Pretty close.
22.
Wait, I thought we were supposed to stop at
20 was the last one I did last night. And I got to this point and I did some fighting more like I did the expression rule. That's the product. Yeah, that's right. Did I do that right? If that's like negative x squared, okay. Okay, so you could take out like an e
Sure.
but
But
it's
we're
not going
doing
to
it.
cancel.
Yeah,
So
fine stuff.
that's fine.
Yeah, exactly.
You could also could you also take out like a x squared? Yeah, x squared out. But like you could, that's just like you're like screwing something up, so you got used to it.
Yeah, that's like the 3x plus 6.
If it's not like over something.
Right. To me, in these problems, simplifying that the
Yeah.
only time to really factor is to factor and cancel.
Okay.
If
Because
you're just
I have a
factoring.
couple examples of, like in the book.
where they did that.
They just kind of,
This is not my desk, but this is awesome.
Yeah, perfectly fine. There is no real hard, fast rule for what is simple. You know what I mean? I mean, it just, the form you want usually depends on what you've done. It's just going to be there. So multiple forms are good. So,
this sucks.
okay. You raise your hand.
I get so lost in like figuring out if it's proportion or chain rule or like what I've done already, what I still need to do. I don't know if I
Yeah, like I don't know where that U squared. Yeah, because basically what you're doing is E raised to something is E raised to that something times the derivative of that something. So that's what you have right there. So it's just right. It's just E to that times that. Then that left alone plus that left alone. Derivative of tangent is the outside, so it's secant squared root inside alone times the derivative. So you got to do the derivative. And then, that was pretty much done. Yeah, because really, I mean, yeah, on product rule is the one where you feel like maybe you want to factor out something, and that's the one where there really isn't anything to cancel. So you usually don't on product rule. Now, what you do be careful of is if you have a 3, something, something, and then a 2, you know, that you put the 3 and the 2 together.